Okay, under modules, I just posted it into modules. I had it in files, but I didn't put it in modules. But under modules, go ahead and pull out the 1.5 part 1 notes. Guys, we're going to do more solving. Solving, you're going to have to group, or you might have to use the quadratic formula. You might have to factor, all that stuff. None of this is going away. So the first thing you need to do is go through our steps. For number 1, if I have x squared minus 3x plus 2, what is the first thing we always look for when we're factoring? GCF. Is there a GCF? No. Is this a trinomial that I could multiply to get a positive 2, but add to get a negative 3? Yes. What are the factors of 2? 2 and 1. So if I have x and x equals 0, 2 and 1, what are the signs to multiply to give me a positive 2, but add to give me negative 3? Negative, negative. You guys agree? Okay, so what does x really equal? 1 and positive 2. Yesterday on your test, a lot of you did really well with the factoring, especially when a wasn't 1. I was very happy with that. A lot of you did really well with that, so that's good. All right, look at this one. We can factor this and then solve it, or you can just go ahead and solve it. But if I have x squared minus 4, that's the difference of what? It's difference of perfect squares. So I could say this is x plus 2 and x minus 2, correct? All right, some of you may not have seen that, or you're not sure if it factors or not. So if I go to solve this, if I have x squared minus 4 equals 0, what do I do to both sides? Add 4. So I have x squared equals 4. Then I do what? Take the what? Take the square root. Good. When I physically put the square root on, what is my answer? Plus or minus. Good. What's the square? Whoops. What's the square root of 4? 2. Just say that was a negative 4. What would my answer have been? Plus or minus 2i. Good. All right, same thing here. Can I just factor this?
Yes.
I can? So what? Okay, so you're solving it. That's good. If I add 8 to both sides, I have x cubed equals 8. So what did you say? How do I get x cubed to go away? Take the what? The cubed root. What that is saying, and since it's an odd root, you don't need plus or minus, but what that is saying is what number times itself 3 times gives you 8? Positive 2. Good. Very good, guys. All right, so moving along, let's look at a problem that's a little more, we don't have to worry about that. That's a little more involved. It says find all the real solutions of the equation. Check your answers. Guys, what you will learn later on, and what I'll talk about a million times, is the highest exponent that you see is how many answers you should have. What's the highest exponent you see? 5. So how many solutions are there to this problem? 5. How do you know if the solutions are real or imaginary? Excuse me? Well, I'm sorry, I should have asked that question differently. When I solve it, what is the difference between the real solutions and the imaginary ones? One has an I. Good. This question is asking for the real solution. So if you come out with any that have an I, that's not what they're asking for. But I'm telling you, the highest exponent tells you how many answers you have. Doesn't always need to be real or not real. When you see these words, solutions, zeros, x-intercepts, and roots, all of those things mean the same thing. It means to do what? Solve. When it asks you for any of those things, Christian, make sure that you understand solutions, zeros, x-intercepts, and roots all mean to do the same thing, solve. So if I look at this, when we are factoring, what is the first thing we take out? GCF. What do they have in common? X cubed. Good, x to the third. So when I take out an x to the third, what am I left with? X squared minus 9. Right away, guys, we should see this. If you don't see that that's the difference of perfect squares, that's fine. You can still set this equal to 0 and solve it. If I set x cubed equal to 0, and then x squared minus 9 equals 0, can I solve both those things? Yes or no?
Yeah, you got it.
Yeah, how do I get the cube to go away?
Squared. Oh.
Or cubed, I know what you meant. So I have x equals 0. And then what do I have here?
You add 9.
So x squared equals 9. Then what?
Square root.
So x equals plus or minus
3.
3. So I have plus or minus 3, and then how many times do I have 0? 3 times. 3 times. Good. But you could also have done this. X minus 3, x plus 3, and then solve from there. So some of you, well, could I have done that? Yeah, absolutely. This is just the same kind of factoring we've been doing. It's just an extra little step. You guys saw this last year. You may not remember it, but you saw it. Okay, what about this? First thing, what do? Take out the GCF. So x squared, and then I'm left with x cubed minus what? 27 equals 0. Set each piece equal to what? Good. So I have x squared equals 0, and x cubed minus 27 equals 0. Now what? Okay, take the square root of both sides, right? So x equals 0. And then what do I do here? Add 27, good. So x cubed equals 27. Then what? Take the cube root. So x equals 3. How many times do I have x equals 0? 2. How many times do I have x equals 3? Good. Good. Because it's an odd root. Good question. Because you can take, like if you had this, Christian, if you had the cube root of negative 27, what number times itself 3 times gives you negative 27? Negative 3. It's not imaginary. So you could have that. Good question. First thing, every single time we factor, first thing we look for, GCF, good. So when I take out the GCF, excuse me, sorry, what do they all have in common here? Okay, I can take out an x squared, good. When I take out the x squared, what am I left with? X squared minus 4x plus 3. Good, Josh. Oh, sorry, I'm not talking to you anymore. X squared, what can I factor? What are the factors of positive 3 that multiply to give me positive 3 but add to give me negative 4? What kind of 3? What kind of 1? X minus 1? X minus 3. Because negative 1 times negative 3 is positive 3. And negative 1 plus negative 3 is negative 4. So set each piece equal to 0. What do I have? So x equals 0, x equals 1, and x equals... How many times do I have x equals 0? Twice. Get in the habit of doing it. I don't know if that's going to be asked on the test or not, or quiz, but just, yeah. That's called multiplicity.
Do you want us to just put 2 times or write x equals 0
Twice,
times?
either way. Multiplicity means more than 1. I have multiplicity. What? How do I have multiplicity? Because I have twins. I had 2 kids at the same time. Oh, isn't that crazy? All right, look at this. What do?
Take out
X squared. Guys, watch what happens when you take out x squared. Look, if I divide out x squared, and x squared, what am I left with? X squared plus 4x plus what? 1. Why is it plus 1? Okay, when you divide something by itself, what does it always end up with? 1. It does not just go away. So now I say, okay, let me factor this. What are the factors of 1 that multiply to give me 1 but add to give me 4? Nothing. So if I can't factor a quadratic, what's that wonderful formula that we know? The quadratic formula. What is my A? 1. What is my B? 4. What is my C? So I have negative 4 plus or minus, tell me.
4 squared.
4 squared minus?
4 times 1 times 4.
All over? Perfect. So if I clean this up a little bit, negative 4 plus or minus, what's 4 squared?
I have a question.
Yep.
The 2 1 is that?
Okay, so what is 16 minus 4, yes?
Yeah.
Okay, over 2. So I have negative 4 plus or minus square root of 12 over 2. What kind of solutions am I going to have here?
The good one.
The good ones?
Bad one.
The real ones?
Yeah.
Why do I know it's going to be real? It's not going to be a pretty number, but why do I know it's going to be real?
Because there's no negative.
Because there's no negative underneath the square root. Good. So I'm going to break up 12, which most of us broke up where we needed to on our test yesterday. Some of us did not, but that's okay. I'm going to break it up into a perfect square, Christian, and a non-perfect square.
That's what I was talking about right now.
Meaning, okay, the good one and the bad one. I could do 6 and 2, right? That equals 12. But neither of those are perfect squares, so it doesn't help me at all. So that's why I chose 4 and 3. What is the square root of 4? 2. So this really has me left with negative 4 plus or minus 2 root 3 over 2. Can I simplify?
Yeah.
Yes. How many times does 2 go into negative 4?
2.
Okay, so I have negative 2 plus or minus what?
Plus or minus 1.
1 square root.
1 square root of 3. Good. So there's my 2 answers, and then I got to go back here. What did I forget about?
X squared.
Yep. So take the square root. X equals 0. How many times does x equal 0?
2 times.
There you go. Good, guys. And remember, the highest exponent tells you how many zeros you have. How many zeros did you know you were going to have at the beginning? How many solutions? 4. I have 2 of them right here. And then I have 2 of them over here. 2 of them are pretty, 2 of them are not. But all 4 of them are what? Real. Yes. You good? All right, let's do. All right, first thing we look for. GCF. Is there a GCF in all 4 of these? No. What do we do when there's 4 terms? Group. We've talked about this. We're going to keep talking about this. We're going to group the first 2 and the second 2. Notice what I did with that negative sign in front of 4. What'd I do? I kept it. We want to make sure that we pull it out. So what can I take out of x cubed and 3x squared? Okay, I'll take out an x squared, and then I'm left with x plus 3. Agreed? Okay, what can I take out of negative 4x and negative 12? Take out the negative 4, and I'm left with x plus 3. Yes? Okay, look, if I take out negative 4. Here we go, let's finish. Let's finish. What do you guys now see is the new GCF? What does both terms have in common? X plus 3. So I take that out, I write it one time. Now it's gone. What happens with the stuff that's left over? They get their own parentheses. Good, draw this. So x squared minus 4 equals 0. Can I factor x squared minus 4 a little more?
Yeah.
Yes. If you didn't see that, that's okay. You could have just set it equal to 0 and then solved it, moved the 4 over. But what are my x's? What are my zeros? What are my solutions? What are my roots? All those things mean the same thing. What does x equal? So x equals negative 3. X equals negative 2. X equals positive 2. Do I have any multiplicity? Do you see any solution? Root, x-intercept. Do you see any of them more than once? No. Positive 2 and negative 2 are 2 different places on the graph, so make sure you guys pay attention to that. At the beginning, what was the highest exponent? 3. So how many answers should I have had? 3. How many did I have?
3.
Oh, beautiful. All right, last one. Oh, yes. What is it, guys? It's a fraction. Therefore, we do what? We skip it. We freak out. We say, I don't know how to do this. Yes, you do. Okay, common mistake. Very common mistake that you guys will make is to say that each of them needs a plus 2. This one already has an x, it just needs a plus 2. That is not the case, guys. This is x. This is x plus 2. This is 1. So if nothing is in common, just because one has an x and one has an x plus 2, those two things are completely different. X plus 2 is not just let me put a plus 2 on the end of the other x and we're good to go. These are completely different. So what we're going to do is we're going to find a common denominator. When we don't have anything really in common, just write everything down. I have an x and I have an x plus 2. So now we're going to do the same thing that we did before. I look at the first fraction, 3 over x. It already has the x What is it missing? Not just the 2. The x plus 2, the whole thing. So I'm going to multiply the bottom by x plus 2. What you do to the top, you do where? Sorry, what you do to the bottom, you do where? To the top. Good. Now I look at the x plus 2, 5 over x plus 2. It has the x plus 2 piece. What is it missing? The x. So if I multiply the bottom by x, then I do what? Top by x. The last one doesn't have either of them. So what do I have to multiply the bottom by? Both of them, x and x plus 2. So then I do the top by x and x plus 2. Now do they all have the same denominator? Yes, what can you do? Cross it off. So I'm just going to rewrite this. It's 3 times x plus 2 plus 5 times x equals 2. We can just say 2x. Well, I'll just say 2 times x plus 2. You guys see that? Now that they all have the same denominator, we did all that. Now it's just a linear equation. What's 3 times x? 3x. What's 3 times 2? Plus, what's 5 times x? Equals 2 times x is, so this is 2x times x plus 2. So what's 2x times x? 2x squared. Good. And then what's 2x times 2? 4x. Now I have x squareds and I have x's. That means I have a quadratic. That means I need to do what? Move everything where? To one side. Can I combine some stuff over here? Yes. So this is 8x plus 6. 2x squared plus 4x. Now let's move everything to the left.
Subtract x and subtract 6.
Okay, so wait, what did you say, Valerie?
Subtract 8x and subtract 6.
Okay, you want to move it to the right, so 2x squared stays positive?
Yeah.
That's fine.
Actually, I'll move it to
That's
the
fine.
x.
So you have 2x squared. What's positive 4x minus 8x?
A negative 4.
Minus 4x minus what? Equals.
0.
Now, to solve, what do we do to solve? Greatest common factor. What can I take out of 2, 4, and 6? 2. So I'm left with x squared minus 2x minus 3 equals 0. Yes? What are the factors of negative 3 that could multiply to give me negative 3, but add to give me negative 2?
Negative 3
Negative
and
3,
positive
negative
1.
Good. Now, guys, you have to set each piece equal to 0, right? When I have just a number out front, write that equal to 0. Will 2 ever equal 0? No, so just cross it off. That doesn't mean anything. So I have 2 answers, x equals and x equals. What are those 2?
X equals 3.
Positive 3 and negative 1. Good. All of that stuff we've seen before. You may not remember it. That's okay. We went through it again. But all that stuff you guys have seen before. So on Tuesday, all right, on Tuesday I'm going to do the second part. It's a little harder. And after the second part, we're going to have practice problems that are going to be due on Thursday. I might actually make them. Yeah, we'll just do it then. Okay, I will upload.